So, what is trigonometry? What is this cosine, sine stuff? And where do they come from? I mean, when I was at high school, none of my teachers taught me like the basis of it. So, whenever I'm seeing, for example, let's say cosine 30, I was just drawing a triangle like this, and I memorized the angles like that, and I was just trying to get help from here like this, right? The ratios, etc. And a cosine was the neighbor one, cosine, so square root 3 over hypotenuse. I was finding it like this, but I never knew why this was the case. Like, what is this? What is cosine? Like, why do we need it? So I'm just going to explain to you the very basis of it. So it all comes from unit circle. So we have this unit circle that we use in order to understand the concept of trigonometry. I mean, it was very useful for me to understand it. So let's imagine a circle, right? And the radius of this circle is 1. Okay? And x-axis, the horizontal one, is called cosine. And the vertical one, the y-axis, is called sine. Okay? And our degrees start from here and goes with this way, to this way, like this. This is the positive direction, okay? Positive direction. So whenever I'm saying, draw me, let's say, 60 degrees, you're just going to come here from 0 to here, right? 60 degrees is going to be like this approximately. You're just going to draw it like that. Okay, and if this side is cosine, right? This side is cosine. Then this side is negative cosine, and this side is negative sine, okay? So let's keep that in mind. And I told you about the radius is equal to 1. Think in this way. This is equal to 1. It's touching to the end of the circle, okay? And so that means this is 1, this is 1. And in the coordinate system, this is negative 1, and this is negative 1. So, let's call this r, okay? R is equal to 1. And in order to find the coordinate of this point, right, where it is touching to the circle, let's call it xy, okay? Xy. What does it mean? The distance it traveled on the x-axis is called x, right? Delta x or x. Delta x means the difference in x. Delta x is equal to x2 minus x1. That's it. I mean, let's keep that. I'm not going to delete it. Okay, delta x is equal to x2 minus x1, whatever. And this is delta y, okay? Or I can just call it x and y. So in here, what do I have? Again, the same thing that we did in the previous video. y2 minus y1 plus square plus x2 minus x1 square. And then square root of it, like Pythagorean theorem. Let's do it. Let's see it. X minus 0. The origin point is 0, 0, right? X minus 0 square plus y minus square. Since this is addition, the order doesn't matter, okay? You can write however you like. Is equal to r square. Take square root of both sides. Take square root of both sides. What do we have? X square plus y square. I mean, why did I even do this? Wait a second. X plus y square is equal to r square. Okay, we have this. That's the formula that we have. And I said this is positive direction, and then this case, this is negative direction. Okay? And what do we have in here? A triangle. A right triangle. Okay? I'm just gonna draw it again. Okay? This is the like side of the circle, right? We have one in here, right? AB, or xy, doesn't matter. B is here, the distance vertically, and this is A. So I'm just gonna teach you, and let's call this angle theta. Theta, beta, gamma, doesn't matter, whatever you call it. Sine is equal to, it's the ratio. Sine is equal to ratio. Adjacent, right, is for theta angle. Adjacent is A, adjacent side. The opposite side is B. This is opposite. And this is adjacent. And as you know, this is the hypotenuse. Sine is equal to opposite over hypotenuse, which is equal to what's opposite? B over 1. Cosine, adjacent over hypotenuse, which is equal to, do not take this is also adjacent. 1 is also adjacent. No, that's the longest side. I'm not taking that. That's hypotenuse because it is opposite 90 degrees. I'm just taking the other one, which is A. Adjacent over hypotenuse, A over 1. Tangent. Tangent, we are gonna deal with this tangent a lot. What does it mean? If I have heard where tangent is used, I would be really happy. When I was in high school, I would have been really happy. So tangent is equal to slope. Yeah, slope. If you are climbing a very steep hill or a very flat one, or close to a little bit inclined one, the slope of this one, for example, is higher than this one. The tangent is higher. Okay? But I'm just going to show it in here. Tangent is equal to opposite over adjacent, which is equal to opposite B over A. Tangent is also equal to sine over cosine. How so? Let me prove it to you. Sine over cosine. Opposite over hypotenuse. I just wrote this. Okay? Over adjacent over hypotenuse. Okay? And I'm just taking this and flipping it to here. If I wanna get rid of the division. What's happening then? Opposite over hypotenuse times hypotenuse over adjacent. See, these are canceling out each other. Opposite over adjacent. Cotangent is equal to opposite of tangent. Adjacent over opposite, which is equal to A over B. That's it. Okay. Now I'm going to also show something to you. I told you this was cosine, right? And this was sine. There is a rule, okay? Which is equal to, you also remember the Pythagorean theorem. So cosine is representing x. Cosine square theta plus sine theta square is equal to 1. That's it. Is equal to 1. Okay, and we have also done that part. Now, I'm just going to show you the signs of these sines and cosines in the Cartesian coordinate system. So as I told you, this is 0 degrees, this is 90 degrees, right? Then 180 degrees, 270, and we are coming back to 360 degrees, right? Just keep this in mind. And if I follow the opposite side, then it is negative 90. Like this is negative 90 if I follow like that. Anyways, this is cosine, sine, negative cosine, and negative sine. So in here in quadrant 1, This is quadrant 1. In here, everything is positive, whatever degree it is. All positive. What does it mean? Like tangent 80, positive. Cotangent 70 is less than 90, positive, positive. Sine 45, positive. What else? Cosine 30, positive. Okay? All. And I'm just gonna write something that will hopefully stay in your mind. All silly turtles crawl. Okay? Why did I write this? I'm gonna show it to you. In here, all of it, the things that we have done in here, tangent, cotangent, these are positive. And in here, in quadrant 2, which one is negative? Let's test it. Let's see. So sine is positive, right? And the rest is negative. That's why it is S. In here, T, the initial of the word, T is positive, which is tangent is positive. And in here, cosine is positive. All silly turtles crawl. Do I like this? No, I'm not using it actually. I just wanted to share it for you. How do I do it? I'm just looking at the coordinate in here. What is it? Sine in this part, in here, look, in this part, sine is positive. In this part, sine is negative. In this region, sine is negative, this way, right? What else? Cosine, after here, in this way, it is negative. So, that's it. Since tangent is sine over cosine, right? Sine is positive over negative cosine, then it is negative tangent, see? In here, in this part, in quadrant 2. That's how I remember it, actually. But maybe you will like this one. Yeah, tangent is positive. And in here, for example, sine is negative in quadrant 4. Sine is negative, right? What else? Tangent, again, still is negative. Cosine is positive. And cotangent is negative. Why? Because it is cosine over sine. Cotangent. And tangent was sine over cosine. Okay. Yeah, we did that. Now, let's try to guess some angles. For example, what is cosine 0? What are you going to do? Draw a unit circle. Let me just draw it straight. I'm a little bit off-centered. I'm going to draw it again. Anyways. Cosine 0. First, draw the degree. 0 degrees. Where is it? Here. It's right here. 0 degrees, right? 0. And then, what is it asking? Go to cosine. Okay, I'm going to cosine and I'm looking at the distance from the origin. 1. Cosine 0 is equal to 1. Okay, how about sine 90 degrees? Where is 90 degrees? It is coinciding with the y-axis. Here. Again, 1. How about 180 degrees? Go from here to here, 180. Let's say sine 180 is here, right here. Does it have any sine value? No, then it's going to be 0. Then cosine 180, negative 1. So do you understand? I'm not hearing you back, but I hope you do. So 270 degrees. Go from the origin go like this way. I'm reaching to 270. It's right here. Let's say cosine. Does it have any cosine value or x value? No, 0. Sine 270. This is -1. -1. And what else? How about sine -270? What about this one? Then what I'm gonna do is this was the positive way, right? I'm gonna follow the negative way, 90, -90, -80, and -270, which is equal to 1, which is also equal to sine 90. See? I'm not memorizing anything. I'm trying to understand, grasp the very core of it. How about sine -90? -1. How about sine -180? I'm going this way. What's happening? -1. Just kidding. 0. Come on. Why? Because there is no sine value. Okay. And how about 360? Cosine 360. I'm going this way. Let's erase these. I'm going this way. Coming back. Where? To still here. 1. Okay? And yeah. So the unit circle is all about that. I hope you understood some concepts. Let's give another example. For example, let's say this part. Let's assume that, just keep erasing it. This is, let's say, 220 degrees, okay? Now, I want to actually show you this. If I'm asking cosine 220 degrees, what is it equivalent to? I drew 220. Then I'm going to just look at the distance. What's the distance in here? If this is 1, I'm just assuming right now, then it would be maybe approximately 0.8 or something, right? But since cosine is negative, I'm just going to put a negative sign. I'm not sure what it is, by the way. I'm just guessing right now. Then, let's draw, for example, we said 220. Let's say here, let's say this is 80 degrees, okay? Now, cosine 80. So it's like 0.1 maybe. It's positive, right? I'm just looking at the distance. Since this is 1, the unit is 1, right? Then cosine 80 would be equal to 0.1. How about sine 80? Sine 80, if sine 90 is 1, sine 80 would be like here. The distance of this, approximately 0.9. I'm just guessing right now. So I'm just finding the angle and then looking at its reflection on the axis. Let's think about this one. It's less than 270. Let's say 250. Sine 250. I drew 250. Okay, good. Then I'm just going to look at its distance on sine. Here, what's the distance? Close to 1. Then maybe 0.9 again, or 8, doesn't matter. But it's negative 0.9. Okay? Then what else? What I can tell you? Let's see. I said sine. And, now I remember. Okay. I'm just gonna compare these two. Watch carefully, please. This one, 30 degrees. This one, -30 or 330 degrees, right? If I follow like this. So I have 30 degrees and I have 330 degrees. So in that case, the distance of these on the x are same. That means cosine 30, my guy, or girl, whatever, is equal to cosine 310 30, because the distances are same. How about their signs? I mean, signs are different. In here it is positive, in here it is negative. Let's say maybe it is like 0.3 something, and this is negative 0.3. But at least the the numbers are same, but the units are different. The positive and negative, the signs are different. Okay, so that will be it for the unit circle. I hope I did my best in explaining this, and now you know at least where the rule sine square plus cosine square xx or whatever is equal to 1. Now you know how this is coming. Now I'm just gonna solve some Pythagorean problems in the next video, and also show you some special triangles. Okay, see you in the next video.